Good morning everyone. Today we are going to discuss ring opening of epoxide. So let's talk about epoxide. So first thing is, what is epoxide? So it is a three-member oxygen containing cyclic ring. Okay, like this. Oxygen has two lone pair. This is also epoxide. Okay, so oxygen containing ring. Now we are going to discuss method of formation of epoxide. So in the method of formation, suppose you have alkene like this. When alkene is treated with MCPBA, this is a reagent called metachloroperbenzoic acid, and it forms epoxide over alkene like this. Okay. Suppose we have this alkene and we are using MCPBA, then the epoxide will be like this. Clear? So this is called epoxide. Epoxide is of two types. One is a symmetrical, another one is unsymmetrical. Symmetrical is like this one. Suppose you have this epoxide. You can see the degree of both carbon is same, 2 degree. Unsymmetrical is this one. Suppose this side we have a carbon containing chain, any side, left or right. This is called unsymmetrical. We can take another example. Suppose this one. Both sides have same. Suppose here any side has 2 carbon and any side just 1. So this is unsymmetrical. Okay. So this is unsymmetrical and this is symmetrical. The reaction of epoxide is carried out in two medium. Reaction of epoxide. The one is acidic medium and second one is basic medium. Okay, so first we are going to discuss acidic and then basic. Acidic medium, the path is SN1 while basic is SN2. So let's discuss ring opening in acidic medium. Ring opening in acidic medium. Suppose here we have epoxide, unsymmetrical, and we are going to take here, suppose HCS3OH in presence of a proton acid. Clear? So what will happen here? Look at the mechanism. Here we have two lone pair on oxygen. In a very first step, protonation. Protonation is what? The oxygen's lone pair will be over H plus. So here we have a bond like this. One lone pair still we have. This is called protonated form. And now here we have this nucleophile CH3OH. And I said that the path is SN1. So SN1 is what? Nucleophile attack on the carbon which is more substituted. So look at this carbon, the positions here. We have this carbon and this. Which one is more substituted? This carbon. Clear? Even you can mark numbering here 1 and 2. So this CH3OH attack at number 1 carbon and this bond is going to break. Clear? So what will happen as a result of it? Look at here the bonding. This is carbon 1 and this is carbon 2. One has a methyl group, one has a methyl group. And now oxygen attack over this one carbon. So it will be like this. Oxygen have a proton, have a positive charge and a proton, and then this CH3. And now number 2, this bond is going to break. So number 2 has OH connectivity. So number 2 has OH. And in the last step, what will happen? This is going to break. So you have this kind of product. Here OH, here methyl, here OCH3. Clear? So this is a final product. Make sense? Again listen me. First step in acidic medium. We are discussing in acidic medium. So in acidic medium, the first step is a protonation and then nucleophile attack on the more substituted carbon. Clear? This is very important. The numbering, it can give you a very clear idea about the connectivity. And in the last, you can remove the numbering. Okay. So this is my final product. We can take another example. Suppose we have this one. Here we have suppose HCl. Clear? So this is a acid, we all knew. So what will happen? So if you look at the mechanism, in a very first step, oxygen attack over the H plus and this bond is going to break. So there is a protonation like this. Clear? And in the next step, we have a nucleophile chlorine. And chlorine 2 is going to attack on the more substituted carbon, this carbon. So you can mark this one as 1, this one as 2. So what will happen? It attacks over this carbon. This bond is going to break. And as a result of it, it will form. So this is my number 1, this is my number 2. Number 1 has a methyl. Number 1 has a Cl as well. And number 2 has oxygen with hydrogen. Clear? So this is acidic medium. Now the next is basic. So ring opening in basic medium. So in basic medium, suppose we have this epoxide. And we are using this kind of base CH3O minus Na plus. So let's discuss the mechanism. Again we can mark numbering 1 and 2. Here the path is SN2. SN2 means nucleophile will attack on the carbon which is less substituted. So this O minus is going to attack at number 2 and this bond is going to break. Always break the CO bond, okay? So as a result of it, look at the numbering. This is my 1 and 2. One has a methyl as a branch, so one has methyl as a branch. And now one has O minus. After breaking, you can see this bond is going to break. So number 1 has oxygen, which is O negative. And then number 2 has OCH3. Clear? In the next step, this O minus is going to protonate from any source of proton, like suppose you have water. So O minus grab this H. So here we have this product. Clear? 1 and this is number 2. So this is in basic medium. So generally the most common basic medium reagents are, the very first one is Grignard one. Grignard reagent, epoxide in basic. Second, Grignard is RMgX, where R is my nucleophile and this Mg is a positive. Second one is acetylide. Acetylide means, suppose this one C triple bond C minus, suppose here any metal like this. Third one, hydride. Clear? And the fourth one, this one, RO negative, any metal, suppose Na plus. So these type of reagents in basic medium is very common. We can discuss one example of Grignard. Suppose we have this epoxide and we are going to treat them with CH3 MgBr in presence of water. So what should be the product? So this is 1, this is 2. This is nucleophile. Reaction is SN2. Why? Because reagent is in basic medium. So this nucleophile, this CH3 will attack on this carbon and this bond is going to break. So as a result of it, it will be like this, O negative. Here we have CH3. And in the next step, it is going to protonate from water. So as a result of it, we have this OH and this methyl. Clear? This is the Grignard one. And acetylide is also very common one. Suppose you have a alkyne like this. The first step is supposed to be Na metal. This is unknown product A. And then Na is treated with this epoxide, supposed to be. Let's discuss some ring one. Suppose we have this one. So what should be A and B? So in that case, Na is a metal, so it will remove the acidic hydrogen of alkyne. So A is very simple, this is. So this is a nucleophile in basic medium and we have this epoxide. So attack is very easy. SN2, this nucleophile will be here and this bond is going to break. Suppose this is 1, this is 2. So as a result of it, look at here. One has this C triple bond CCH3. Number 2 has methyl as well as O negative, and in O negative it will protonate from water. So we have alcohol here like this. Clear? So this is all about epoxide. In the next session we will discuss few more reactions. So this is all about the epoxide. So thank you so much for watching this. Please share and subscribe this video.